Okay, now coming to the next topic in the C programming language, that is time and space complexity. So, what is a time complexity, and then what is a space complexity? First, to take some theory, then we will take some examples how to find time complexity, how to find space complexity. First of all, time. Time complexity is the time taken by the process or a program to complete its execution. Okay, generally, the time taken to complete the program, the execution is called time complexity. Okay, so actually, what is the process? What is the program? Okay, so process means you take this is hard disk or secondary memory. Okay, you take this is one more memory that is called RAM. Okay, so when you execute a program, okay, first of all, when you write a program, the program, I mean your C file is going to store in the hard disk. Your C file is going to store in the hard disk. So when you execute this C file, that is fetched into the RAM. Okay, same file. Okay, when the C file is stored in the hard disk or secondary memory, that is called program. Same C file, when it is fetched into the RAM, what is the RAM? Random access memory. Okay, or you may call primary memory. Okay, so when the same C file is fetched into the RAM, okay, while its execution, this is called process. Okay, this is called program, this is called process. Okay, that is the difference. That is what process and then program. Okay, now coming to the here time scales, here time scales with increasing input size. It means the time is depending upon the size of the input. That is the meaning. Okay, so the time may increase, the time may decrease. Okay, depending upon the size of the input. Okay, I will take examples, no problem. Okay, now coming to the there are okay, so in this way you are able to denote the time complexity. What is the denote means what? For example, if you want to measure centimeters, what is the denote? You are going to use cm shortcut. Okay, if you want to measure I mean distance in some other way, you may use kilometers. Okay, that is what this is called denotion. Okay, this is called denote. Okay, for example, if you want to measure some water, what you take? Liter. Okay, like 1000 liters, 1000 ml. Okay, if you want to measure height, what you are going to use? I'm going to use the okay centimeter or meters or feet or inches. Okay, this is called how to denote the so and so things. Same coming to here. Okay, using this sigma, so that is called best time complexity. It means when you denote sigma, okay, when you sorry it is this is gamma. Okay, so this is gamma, not sigma, it is a gamma. So when it is gamma, this is the best time complexity. Okay, so when you take theta, this is called average time complexity. Okay, when you take big O, that is called worst case time complexity. That is the meaning here. For example, I am having three numbers, so n, okay, n square, so and then log n. Okay, so in this one, which is the best one, best time complexity? It means which is the program, which program is having a low time complexity? This is, so then how to denote? Like this, gamma of log n. So this is the best time complexity compared to the n and n square. Now again, in this, which is the best? I mean, you take average in these three. Which is average? That is n. What you write? You write it as a theta of n, nothing but it is the average case. Now in these three, which is taking a more time? It is n square. Then how to denote? You denote as a big O of n square. Okay, it means what? So this is the best time complexity, this is the average time complexity, This is the worst time complexity. That is what meaning. Okay. Okay, always you have to choose the best time complexity. It means the program which is running in a very low time. Okay. Okay, very less time that you have to take, that is called time complexity, or best time complexity. That is what. Now coming to mean programming, three things are very important. One is time, second one is the space, the third one is the energy. What is energy? Nothing but the battery power. Okay, so the battery power. Okay, so these three are the very important metrics coming to the programming language, programming side. Okay, so one is time, second one is the space, third one is the energy. So which you have to choose? For example, I am having a three algorithms, a1, a2, a3. Which you have to choose? For example, I am choosing the a2 algorithm. Why? Because it is taking the less time to complete its execution. Okay, that is one metric. Second one, what? It is occupying less space compared to the a1 and a3. Okay, also it is consuming less energy. Okay, it is consuming less energy compared to the a1 and a3. So then what I choose? I have to choose the a2 algorithm. Okay, that is what we have to choose. Less time complexity, less space complexity, and then less energy consuming algorithm. Okay, that is about the time, space, and then energy. Okay, that is about the time complexity. That is the purpose of a time complexity. Okay, so one is gamma, second one what? Theta, third one equal to big O notation. Okay, so this is the theory. Now coming to the examples. Now coming to examples, in the exam they will ask. Okay, I'm taking some examples here. Example: void main int a equal to 5, b equal to 10, sum. Okay, so a is a variable integer, b is a variable integer, sum is a variable. Now what I am finding? I am finding the addition of two numbers. Okay, now how to find? Always you have to make one node. You have to check the program. Okay, you have to check the program whether the program having a for loop, while loop, or do while loop, or any recursive programs. The concept of recursive programs you can understand in the unit 4 or 5. So meanwhile I am talking about the iterative programs. So already I told in the previous class what is the meaning of iterative programs. The program which is having the for loop, while loop, or a do while loop is called a iterative program. Okay, now see here, in this example, I don't have any loops. Okay, I don't have any for loop, while loop, or a do while loop. Okay, then what you say? So here I am executing this statement. Okay, I will take very simple. I am printing this statement only one time. Okay, one time. Okay, so size equal to how many variables I am taking? Size of the input. Okay, 1, 2, 3. I am taking 3 inputs, big O of 3. So 3 is a constant. Actually it is not n variables. It is not n variables. So I am printing this statement only one time using 3. Size of the input, how much? Size of the input is the 3, big O of 3. So when you generalize, you make it as the big O of 1. 3 means constant, 1 means it is constant. So then what you write? So this is the answer. Here no loops, no recursion, so only one arithmetic operation. Then big O of n is the constant. This is the answer. So always you make one note. When you write the answer, don't write omega of 1, don't write theta of 1. You write as a big O of 1. When you compare, okay, when you compare, you write like this. Okay, when you compare n square log n, you write omega theta big O. But when you write single answer, you take only big O of n. Okay, this is the answer for the first example. Now take second example. I am taking second example here. Void main int n equal to 5. So I am having size of input equal to 1. Next one, what? I am running the for loop. See, by observation I am getting the for loop here. Then what? So this for loop is running n times. Don't think about 5 6 7, not that is meaning. So this you have to think, I am running this for loop as a n times. So you write as the size of the input is n, here one variable n. Okay, or you think one more way, I am printing this printf percentage d for n times. So you may I may take 5, I may take 7, I may take some n number. Don't think about this. You have to think about the number of variables. Here how many variables? I mean 1 2 3 size. Okay, I am taking 3 inputs. Okay, now see here I am taking the one input, I am running the program n times. Okay, size equal to the size of the input is n. Okay, even though I am taking a one variable, you write it as a one. Second one, what? I am running a iterative loop n times, then answer is n plus 1. Okay, when you generalize, you write it as a big O of n. Okay, that is what answer. The loop run n times, I am printing the I value n times. Then what is the time complexity? It is big O of n. Okay, now take one more example. So void main. So here it is, size of the input is one input I am taking. Second one, what? Here this is, see, by observation this is outer for loop, this is inner for loop. Okay, the outer for loop I am running n times, the inner for loop I am writing n times. Okay, I mean running. See here the size of the, I am taking only one input. Okay, second one, what? N inputs. Then so outer loop run n times, inner loop run n times. Then what will be the output? So which is equal to total n into n, which is equal to big O of n square is the answer. So time complexity, okay, time complexity equal to, it is big O of n square. This is the answer. Okay, now take one more example. Void main int n equal to 16 while n is greater than n equal to n by 2, print percentage d n. Now what is the while? It is iterative loop. Okay, now see how to solve this problem. Now you take some number. Okay, already they have given n equal to 16. So n equal to 16. Okay, second time what will happen? Okay, second time when you run the n, what will happen? 16 greater than 1, condition true. Then what? N becomes how much? 16 by 2, which is equal to 8. Okay, second time what? Again I go to same place. So again I go to the same place here. Okay, okay, then what will happen? N becomes actually n becomes 8. Now 8 by 2, which is equal to 4. Again where I go to the same location. Okay, same location. Then what will be the n? So 4 by 2, which is 2. Okay, second time what? And 2 by 2, which is equal to 1. Finally what? When 1 mean n is greater than 1, condition false. Okay, I'm running the loop n times. Okay, you don't think about 16 here. That is for limitation I have taken. Okay, you think as a generalize. Then what will happen? So then what will happen? See, the loop stops when n is greater than n. That's what. Okay, when n becomes 1, it is going to stop. 1 greater than 1, condition false. When you generalize, starting n equal to what? N by 2, n by 4, n by 8. Okay, that's what. Okay, it is decreasing, the value is decreasing up to 1. See 16, 16 by 2, 16 by 2. Next one, what? 8 by 2. Okay, 8 by 2. Next one, see, you write what is 8 by 2 here. I mean n is 16, that is n becomes 16 by 2. Next one, what? 8 by 2, 4 by 2, and so on up to n. Okay, in generalize, when you generalize. Okay, suppose the loop runs k times. K means what? Okay, it is 1 2 3 4. Okay, the loop runs k times. like 4 times here in our program. Then after k iterations, when it is going to halt, okay, n becomes 1. See, I am generalizing as n by 2 power k. See, n by 2 power k. Say for example, if I take here, so if I take here, what is n by 4? You write as a n by 2 square. Okay, next what you write, n by 2 cube. Next what you write, n by 2 power 4. That is what n by 2 power k. Okay, second time, third time, fourth time. That is what fourth, k equal to 4. Okay, 2n by 2 power k. When I am going to stop, when it becomes 1. So when it becomes 1, the condition is going to false. Then what you write, so this is small, okay, n by 2 power 4, 16 by 2 into 2 into 2 into 2, 16, n becomes 1. Then only I am going to halt. What is meaning of halt? I am going to end this while loop. Okay, that's what. Now you shift this to this place. Okay, n by 2 power k, you shift to that place. Then 2 power k equal to 1. Then when you modify it as k becomes log n base 2. Then what you write finally, so time complexity equal to big O of log n base 2. This is the answer. Okay, so in this way you have to write the, in this way you have to solve the program. Okay, now take one more example. Take one more example. Now see here, void main I. So I equal to 0, I square less than or equal to n, I plus plus. So what you do, so I square, I am taking this, I am taking this, I square less than or equal to n. You shift to square to the right side. Then what will happen? It becomes a square root of n. Then what? This for loop I am going to run for big O of root n times. Okay, root n times. That is what answer. Okay, so time complexity equal to big O of root n. This is the answer. Okay, so in this way how to solve the time complexity for the given programs. Now coming to the space complexity. Okay, so what is the space complexity? Take a theory. How much extra memory an algorithm needs to run? This is what I mean space complexity. In time complexity, we count the input. What I am counting? So I am counting root n times. Okay, I am counting, okay, counting the root n times. Okay, size of the input, size. Okay, here 1 2 3 3 3 size equal to 3 size. Okay, here 1 plus n. Okay, that is the size of the input. Okay, so like that. Okay, so now come to the space complexity. We have to think about what is the space occupied by the so and so. I mean, you have to think here variables. Okay, how many variables? So here in space complexity, we don't count the input, but we focus on the copying the input occupying the memory. Okay, I'll take example. It is very easy. Directly I'm taking example. So okay, I'm taking previous example. So for this void main, how many variables I have taken? So a equal to 5. So this is, for this I have to find a space complexity. So a b sum. Okay, then what? So in the memory, okay, in the so and so memory, so I want to store a, I want to store b, I want to store sum. Okay, so 3 variables occupied in the memory. So how much? 3 means what? It is constant time, sorry, constant space, which is equal to big O of n is the space complexity for the first program. So what is the first program? This is for this program, the space complexity is, this is the space complexity. Now take one more example. Now I am taking void main int n equal to 5. Okay, now so for this variable, for this variable one memory, okay, assume. So here int array of n. So now see here, I mean how many cells I have to give to occupy this n? I have to give n cells. Okay, n cells. It means what? So in the memory I have to give 1 2 okay, 3, 4, and so on up to n cells. I have to allocate n cells. You don't think about the size of the input. That's what n equal to 5, not like that. Generalize, okay. So then what will happen? So n equal to 5, it means what? So this is for this one variable, one cell, size equal to n. How much it is? N. Size equal to n. Then what will happen? Okay, so I'm not thinking about the for loop. I'm not thinking about the for loop. Okay, I am not thinking about the size of input. Okay, see, I am copying. Okay, I am copying this value into so and so location, again this value into so and so location. Like how many times I am copying? N times. It means I have required n cells. Then what will be the space complexity? So here I am copying array of size equal to n, so space complexity equal to big O of n, like that. Okay, now in the above program, okay, in the above program, if I take can you tell what is this? This is the 1D array. Okay, that is unit 3 actually. So it is 1D array. Okay, this is the 2D array. It means what is the 2D array? It is, I mean, this is what 2D array. One second, I'm drawing. Nothing but a matrix. So first row, second row, third row, first column, second column, and then third column, and then fourth column. Okay, so this is what n cross n. Okay, so then what I have to allocate? N cells to store the row, n cells to store the column, which is equal to n into n square. So this is the space complexity for the when the array is array of n of n. Okay, this is the space complexity. Okay, now take one more example. Here I'm taking here. So generally recursive program that will come in the unit 4 and 5. Recursive program means if you call the same program some n number of times. Okay, if you call the program, if you call the same program again and again, that is called recursive program. Okay, see, this is a program. So from the main I am calling the divide. Then where I will go? So I will go to here, do something. Okay, so then again what? See, by observation, see, in this statement I am calling same function again. Okay, so here, so that's what you can understand the unit 4 recursive functions. See, I am calling this function one more time. Then where I see, now the name is same, but these are only different. Okay, this is called recursive programs. From main function I am calling divide. Where I am going, I will jump to the this location. Again what? From here I come to like this. Again I see divide of n by 2. It means what? Again I'm calling same function. Okay, like this I'm calling same function one more time. Again do something until condition false. So always you make one note, when there is a recursive program you have to use a one stack. Okay, so what is a stack? Stack is a one type of a memory element. Memory element means, so this is one memory. Okay, here I have to store some data, that is called memory element. So that will come, you understand, in the second year actually. Okay, stack is a one memory element where I am going to store some data. Okay, like your bag. Okay, so assume, so for example, if you take a box, the storage space is very less. Where pocket, that is also one storage place. Bag is a one storage location. Different names: bag, pocket, box, like that. So like that, stack also one type of a memory element where you are going to store some data. Okay, that is called, okay, that is secondary. So what I have to say, when there is a recursive function, so stack come into picture. That you have to make a note. Now see here, now what happened? So I am calling first time 16. Again what? By 2. That is what? 16 is calling from n equal to 16. Then what will happen? This becomes 8 by 2, 8, 16 by 2, 8. So this calls this. This is going to call this. This is going to call this function. This is going to call this function. That is what, see, recursive call. See, are you understanding this? This function is calling same, but what is the difference? This is difference. This is calling same function. What is the difference? This is difference. Okay, that is called recursive function. Recursive. Okay, okay. Now what is the meaning here? Same as previous one. Okay, n by 2 power k less than or equal to 1. That is what. Okay, so when I have to end the recursive call, when this condition is false, when the condition false, I have to stop the recursion. Then so n by 2 power k. Okay, that is what? N by 16, n by 8, n by 4, n by 2. Okay, like that, n by 2 power k. Then what you do? You update. When you write like this, this will modify as like this: 2 power k greater than or equal to n. So when you shift that this to right side, this will becomes the log n base 2. Then what is the space complexity? Big O of log n base 2. This is the space complexity for the given program. Okay, so in this way you have to solve the, you have to find the time and space complexity. Okay, you have to find the time and space complexity. Okay, that is all about the time and space complexity. Now coming to next topic. The next topic is problem solving strategies. Okay, problem solving strategies. Now what is that? So generally, coming to what is the situation in the software field, first they will give you one problem for you. Okay, you have to choose the best algorithm. That's what I told. Okay, where I told here, see, so a1, a2, a3, for a single problem you write many algorithms. Many means some m number of algorithms, n number of algorithms. So a1, a2, a3, which you have to choose the algorithm which is having a less time complexity, less space complexity, also consuming less energy. That you have to choose. That is what. So choose the best algorithm. Then after the algorithm you write a program. Then you test the program. What is in testing the program? Testing the program means you have to give the input, check the output, whether the proper output is coming or not. Finally, what maintenance means? You have to update the program. Okay, the meaning of a maintenance is you have to update the program whenever there is a requirement. Okay, okay. Now coming to the problem solving strategies. So there are many are there. So coming to our syllabus, they have given top down approach and then bottom up approach. Okay, so generally some more are there. One is, second one is divide and conquer, greedy method, dynamic programming, backtracking, etc. These are the problem solving strategies in the programming language. Not only C, it may be any programming language. These are the strategies. Okay, so coming to our syllabus, they have given the first one, that is top down up and bottom up approach. So these are not given in your syllabus. Okay, now we'll see what is the top down approach and then bottom up approach. Okay, so what is a top down and then bottom up approach? Very simple. Actually, this topic, if they will give in the unit 4 and 5, you may understand very clearly. Now coming to top down approach. So for theory document, I will upload in the link section in my, okay, under the video. There I will share. You download from that. Okay. Now I'm taking examples. First, what is a top down approach? So top down approach means, okay, so from the main, okay, so from the main function, okay, from the main we have to start. Okay, from the main we have to start. Then what? I am dividing the big problem into small sub problems. Okay, so I'm taking a small example. I have to find the addition of two numbers. So I'm taking for convenient purpose. So this is one module, this is one module, this is one module. Okay, it means the program is very big. Assume that I am dividing the big program into small modules. That is called, okay, that is what. Now what is the top down approach? First, from the main we have to start. That is what, top down. Okay, from main we have to start. Then where I will go? When I see take input, I will go to here, do something, again come back to the this location. Okay, then again what I will do? So perform sum. It means what? Addition of a two numbers. So when I call this, again where I will go? I will go to this place, do something, again come back to the this location. Finally what? So finally, okay, I want to print the result. So this is the function, do something, I'm going to print the result, again come back to the this location. Okay, that's what. So from the main I am moving down. Okay, do something, do something, do something. Okay, the big problem is divided into small sub problems. That is called top down approach. What is a bottom up approach? Okay, first you write all modules. Okay, first you write this module. First you write this module, first you write this module, first you write all the modules, then you use whenever you want. Okay, understand? Bottom up approach means what? First I am writing a modules. This is what is a module? Nothing but a program again. This is a some piece of program. Okay, some C file. Okay, this is one module, this is one module, this is one more module. Then what I do, whenever I want I will use, okay, this in the main function. If I want this, I'm going to use this in the main function. If I want, I'm going to use this in the main function. That is what bottom up approach. It means what? I am not starting from the main function. First I am writing all modules. As a programmer I have some knowledge. Okay, as you have some knowledge, so you know what are the modules required in your project. Then write all the models. This is one function, this is one function. Whenever you want, we use in the main function. That is what bottom up approach. Okay, so generally both are good. Depending upon the situation we have to use. Okay, okay, that is all about the problem solving strategies. Okay, for the document I will give a link you download from the below the link. Okay, I will share the link below the channel. Okay, so what I want to say, okay, till now we discussed from lecture 1 to the lecture 15. You listen all these videos, definitely still there is a lot of pending is there, but for now I am saying you listen from lecture 1 to the lecture 15, everything is in that. Okay, listen once or listen 2 times, then you are able to understand very well. Okay, okay.